This is the engine on the Beechcraft Duchess. The engine is a 0360 A1 G6D engine. The engine has 4 cylinders, and this right here is the unfeathering accumulator. We'll talk about this in a bit. Now, the acronym for this engine is LHANC. It's a Lycoming, horizontally opposed, air-cooled, naturally aspirated, direct drive engine that has a carburetor. The engine is 108 horsepower at 2,700 RPM. The Beechcraft Duchess has a constant speed prop system. The job of the constant speed prop is to maintain the selected RPM at different stages of flight. There's 2 positions, feathered and unfeathered. This prop right now is in an unfeathered position, meaning it has a low pitch. One thing pushes this prop to unfeathered, and that's oil pressure. Now, the feathered position is a high pitch when this propeller blade moves back. 3 things push this to feathered. We have the hub spring, we have the counter weights, which we can come around and I'll show you real quick. These are the counter weights. And there's a nitrogen charge, which forces this to a feathered position. When we have an engine failure, we move this prop to feathered so there's less drag on the aircraft. If the relative wind is hitting this propeller from this angle here, this is producing more drag. That's what I mean when I say engine windmilling. In a feathered location, it twists back on itself and it's more aerodynamic, providing us less drag. The main components of the constant speed prop are the prop governor, the flyweights, and as we talked about, the 3 components that push this to feather. In the airplane, the blue knob is what we use to control this system. Now, when you're doing your check ride, and when we're doing training, we're gonna intentionally shut down one of these engines to practice what it's like to be single engine. A part of this practice is restarting the engine. To assist with that, we're gonna use the unfeathering accumulator right here. This side has stored nitrogen pressure at about 100 PSI. This side has oil pressure. And when we push that blue knob forward, that oil pressure compresses the nitrogen charge and shoots it forward to unfeather the prop. Another cool thing about this constant speed propeller is that it will not feather on the ground below 950 RPMs. Why? Because there's something called lock pins in this system that prevent it from unfeathering below 950 RPMs. Because a start after a propeller is feathered can be difficult. The gear on the Beechcraft Duchess are electrically activated, hydraulically actuated landing gear. What that means is we have a landing gear switch in there that electrically activates a signal to send hydraulic fluid down to the gear. When we put that gear to the down position, low pressure hydraulic fluid forces the gear to the down position. Springs and braces hold the gear in a down and locked location. When we put the gear to up, high pressure fluid forces that gear to rise and will be in the up position, held up by that hydraulic pressure. Now, when in the cockpit, we have 3 lights. When the gear are down and locked, we have 3 green lights. Those are micro switches that are pressed when the gear is in the down and locked position. When the gear is not pressing the down nor the up limit switches, we see the in transit light. When it's pressing the up limit switches, we don't see any light in the cockpit. Now we're gonna take a look down here real quick. We're gonna see a couple key main features of this gear system. This is the spring we talked about, and this right here is called the squat switch, where my finger is. You can see that little piece hitting that metal piece right there that comes up with this electrical signal. And the job of that is to prevent gear up mishaps on the ground. Let's say we were in the cockpit and your little brother was in the plane with you and he accidentally just pulled that gear handle up. Well, that could be a bad day because the gear would fall and the plane would be on the ground. We don't want that, so this squat switch here prevents the gear from coming up when it is pressed. Gear up mishaps are prevented through a couple of different things. First, when the throttle is below a position to maintain flight, about 15 to 16 inches of manifold, you'll hear a gear horn. Secondly, when the flaps are past 16 degrees and the gear are not down, you'll also hear a gear horn. And finally, when the gear is switched up on the ground, you'll also hear that gear horn. Now, the gear won't fall up because the squat switch is preventing that. This airplane has a combustion heater. It's a 45,000 BTU Dranitol heater. The heater uses 2/3 a gallon from the right tank per hour. It's important to know you should turn this heater off about 5 minutes before you land so it has time to cool down. In addition, when it reaches above 300 degrees, it'll naturally shut off and needs to be reset and inspected by a mechanic when that happens. The heater is behind this panel, the exhaust is down here, and the intake is right here. The electrical system on this aircraft is a 14-volt system powered by two 60-amp alternators. You can see one of them right there. In addition, there's a 12-volt battery that charges at 35 amp hours. One alternator can pick up a load for the entire system. The fuel system in the Beechcraft Duchess has 103 total gallons and 100 usable gallons. We use 100 low lead, which is blue, and 100 octane, which is green. The thing about the multi-engine is that you have something called fuel crossfeed. What fuel crossfeed does is it transfers fuel from this right tank to the left engine and from the left tank to the right engine. It's not a fuel transfer, but it forces it from the right tank to the left engine and vice versa. Now that we're inside the plane, we're going to talk about how to use the crossfeed system. Let's say my left engine is inoperative and I want to use the left engine fuel or left tank fuel for the right engine. What we're going to do is we're going to turn our right fuel pump on. We're going to turn our left fuel to off and our right side to crossfeed. Once fuel pressure stabilizes, we can turn our pump off. Note, crossfeeds for level flight only. Now let's say we're coming into land and the landing gear do not come down. Well, first we're going to go through our clam checklist. Make sure our circuit breakers are in. Make sure our nav lights are off because the nav lights will dim the 3 green lights. Make sure that our alternator is on and our master switch is on. After we do that troubleshoot, we can pull a throttle back and make sure that we don't hear the horn. And if none of that works and we still don't think that the gear is down, we can use our emergency dump valve. We took the carpet out so you can see a little bit better here. I'm gonna flip open the emergency dump valve and I'm gonna use our tool to turn this valve to allow the gear to free fall. We must be below 100 knots in order to use this. Well, something that you might get asked on pre-flight is why are there 2 stall horns? Our A&P Owen's in the airplane and he's operating the flaps. Right now they're at 0 degrees and you're gonna hear this left wing stall horn works. Now Owen, drop the flaps for me past the first notch. You're gonna hear this stall horn is not working on the left wing. Let's go over to the right wing. The flaps are in the same location and the right wing works. Owen, bring the flaps up for me. And you guys are gonna hear when the flaps are up, the stall horn doesn't work, but the left one would.